Hello everyone and welcome to this video on the Python programming language. So in this video, I will try to answer the question, would I profit from randomly having a position in the S&P 500? And if so, would it be more profitable than simply holding the asset? All right, so I'm currently on Google's website. It's called colab.research.google.com, and I'm on it because it makes it really easy to start programming in Python. So if you're going to code along with me, go ahead and go to this website and then log in using your Google account and start writing your code by clicking on this file button here and then click on new notebook. Once you do that, a new tab will open up for you, and then eventually a new cell will open up for you. And in this cell, I'm going to import the libraries that I need to use for the program. So I'm going to import pandas as PD. I'm also going to import numpy as np, and I'm going to import matplotlib.pyplot as plt. Okay, and then I'm going to run this cell by clicking this button here to the left, and this will let me know if I made any mistakes. Now, just so you know, you can get the code in this video or the data set from this video, or just support the channel on Patreon at patreon.com/computerscience, and I will leave a link for that in the description below. Also, the material in this video is purely educational and should not be taken as professional investment advice. So with all that being said, let's go ahead and continue. I'm going to click on this code button in the top left here to create a new cell. And now in this cell, I want to get the data for the S&P 500. So I'm going to create a variable called data, and I'm going to set it equal to pd.read_csv, and we're going to read in the CSV file. The CSV file has a name, and the name is spy_2yr.csv. Now I have to upload that file to Google Colab. So to do that, I'm going to go ahead and click on this folder here, and I'm going to click on upload, and then I'm going to upload that spy_2yr.csv. And while I'm at it, I'm going to go ahead and upload this spy_12yr.csv. All right, so let's go ahead and open both of those. I'm going to click OK here. So now both of those files have been uploaded. Let's go ahead and exit this, and let's show the data. So I'm just going to type data here. I'm going to go ahead and run this cell, and now we can see the data for the S&P 500 for about 2 years. All right. So let's go ahead and change a few things. Let's change the indices to be the date, and that's easy enough. We can do that when we upload the file. So I'm just going to put, when we read in the file. So I'm just going to put parse_dates here, and I'm going to set it equal to true. And then I'm going to set index_call equal to our date column. And let's run this cell now, and let's see what the indices look like. It did not like that because the name date was not defined. So let's take a look at our data again. I'm just going to remove all of this. Let's go ahead and run it. And we do have a date column. So I'm just going to put it all back. Parse_dates equals true, index equals call, and index_call should equal, I need to make this a string. So we need to put the single quote date and then single quote. All right, so let's go ahead and run this again. And now we have our indices as our date. All right, so let's go ahead and create a new cell. And now in this cell, I'm going to calculate the daily returns. All right, so I'm going to create a new column called returns. So I'm just going to type data and then create that new column called returns. And I'm going to set it equal to data adjusted close dot pct_change, percentage change. Okay, and so now I'm using this adjusted close column up here, and we're getting the daily returns of that adjusted close price. All right, so let's go ahead and let's run this. Everything looks good. I'm going to create a new cell, and now I'm going to define the buy and hold strategy. So this will allow me to see the returns from just holding the S&P 500 asset. So I'm just going to type data. I'm going to create a new column. It's going to be called buy and hold, or buy underscore and underscore hold. And I'm going to set this equal to 1 plus data returns. And I'm going to get the cumulative returns. So that's easy enough just by typing .cum prod with left parentheses and right parentheses. Okay. All right. So my returns are going to be some decimal value, right? And so we're going to add 1 to that. So I hope that makes sense. But anyways, let's go ahead and continue. I'm going to run the cell. Let's create a new cell. And now here I want to define the random positions. So this means I will have a position in the S&P 500, or I won't have a position in the S&P 500. So this is going to be 1 and 0. All right, so I'm just going to type data. I'm going to create a new column called position. I'm going to set it equal to np.random.choice. So it's going to randomly choose one of our choices. So we're going to choose, or we're going to create our choices, which are 1 and 0. Right, so these are the two choices that we have. Either we have a position with the 1, or we don't have a position represented by the value 0. Okay. All right, and the size of this column will be equal to the length of our data set. All right, so let's go ahead and run this. So now we have a bunch of random positions. So let's go ahead and create a new cell. And in this cell, I'm going to set the first position to 1. All right, so data position will be equal to, data position at position 0 is equal to 1. All right, so let's go ahead and run this. Great. All right, so now let's create a new cell. We get a little warning, a little message here. Everything's fine though, so we're good there. Now let's go ahead and define the random strategy returns. Okay, and it's going to be very similar to what we did up top here. So I'm just going to highlight all of that, copy using Control C, come down here and paste it using Control V. And this time, instead of adding this to the column buy and hold, we're going to create a new column called random, and we're going to get the cumulative returns. But this time we're going to multiply that by the positions. So let's put times data position. Okay. All right. So let's go ahead and let's run. Let's get rid of this comment here. And let's run this. All right, let's create a new cell. And now we're going to simply plot the two strategies. And let's see what everything looks like. So I'm going to type plt.plot, and we're going to plot the data buy and hold column. And let's give it a label. So the label will be buy and hold. All right. Next, we're going to plot the random trading strategy. So just type data, put random here. The label will be random. Let's give the X ticks a rotation so that it looks really good. So I'm going to type pt.x ticks rotation equals 90 degrees. So we're just going to rotate them 90 degrees on the plot. You'll see when this is done. Next, type blt.legend because we want our legend, and then blt.show to show our plot. So let's go ahead and run this. All right, looks like I misspelled rotation here. Rotation. Let's go ahead and run this again. And look at that. We have our plot. All right. So in this orangish yellowish color is the random trading strategy, and in the blue is the buy and hold trading strategy. All right, so let's run this again. The orange should change if we rerun the whole program actually, right? So let me just run this from the top, runtime, run all. Then I can see that the orange line did indeed change. All right, so let's go ahead and create a new cell. And now I want to show the amount of money you would have after a $1 investment. And we're going to just write a few print statements here. So a $1 investment for buying and holding the S&P 500 would be, and we're going to put a dollar sign here, comma, I'm going to put data buy and hold, and I want that last value in our data set, and I want to round this number to 2 decimal places, so I'm just going to put round here and comma 2. So I'm going to round it to 2 decimal places. I'm going to highlight all that, copy using Control C, and then come down here and paste it using Control V and change just a few other things to see how much we would get back from the random trading strategy. So I'm going to remove this buy and hold here, and I'm going to put random, and then I'm going to remove this buying and holding here for random trading strategy. All right, so a $1 investment for the buying and holding strategy. For holding the S&P 500 would be this, and a $1 investment for the random trading strategy for holding the S&P 500 would be this. All right, so let's go ahead and run this. Okay, and we can see that a $1 investment for the buying and holding strategy for holding the S&P 500 would be $1.25. So you would have gained an extra 25 cents from about 2010 to 2012. And a $1 investment for the random trading strategy for holding the S&P 500 would be $1.28. So you would gain 28 cents, and 28 cents of course is more than 25 cents. So in this case, the random trading strategy actually performed better than just holding the asset. Now that's very, very interesting. So what we're going to do is we're going to go ahead and run this again. So I'm just going to run all, click run all here. And we can see that that same random trading strategy beat the buying and holding trading strategy again. Now again, this is a short term, right? This is only two years worth of data. Now let's take a look and see exactly how this random trading strategy performs on a longer time period. All right, so I'm going to come back up here where we uploaded our data, and remember that we uploaded 2 files, right? So I have the spy_2yr.csv file and the spy_12yr.csv file. So we're going to now use that 12yr.csv file, or spy_12yr.csv file. All right, so I'm going to go ahead and exit this. I'm going to run this whole application again. So I'm going to click runtime, run all. Let's scroll down now with our new data, and now we can see that that strategy actually doesn't seem to perform as well as we thought it did, right? Now we are getting a return of $2.64 from our $1 investment from the random trading strategy, and from the holding trading strategy, it's not really a trading strategy, right? From holding the asset, we are getting $4.86 from our $1 investment. So in this case, it beat it, right? So let's do this again. Run time, run all. And again, holding outperformed that random trading strategy. Let's do it one more time, run all. Okay, and once again, it was beaten. And so we could probably run a bunch of simulations to keep trying and see just which one outperforms the other most of the time. But from this small, and let me emphasize, very, very small sample size, and from us running it a small amount of times, it looks like the buying and holding strategy actually outperforms the random trading strategy. So in conclusion, it looks like just buying and holding a position would be more profitable than randomly having positions in and out of the S&P 500. At the same time, it looks like even randomly going in and out of positions in the S&P 500 could be profitable, because every single time we are seeing that the value here is more than our initial value, or the initial amount that we put in, right? So that's really good. So maybe the main takeaway here is to just start investing. But again, this isn't financial advice, so do what you will with that information. Thanks for watching the video, and a special thanks to the Patreon supporters on patreon.com. Again, if you would like to become a supporter of this channel or get the code or data set, I will leave a link in the Patreon page, which is patreon.com/computerscience, and I'll put that in the description below. Thanks for watching, and I hope you all have a great day, and I'll see you in the next video.